We are counting down the 8 programming languages every developer encounters, from code powering blockbuster games to the tech behind AI breakthroughs. Whether you care about speed, safety, or massive job demand, each language on this list has earned its inevitability across the digital world. Which one tops them all, and which quietly dominates entire industries? Let us begin the countdown with number 8. At number 8 is C#, a language born at Microsoft in 2000 under the guidance of Anders Hejlsberg. Originally crafted to modernize Windows development, C# now powers everything from industrial automation to blockbuster games. Its influence is unmistakable. Unity, the world's most popular game engine, relies on C# for scripting, enabling about 70% of all mobile games released today. Beyond gaming, C# has grown with .NET Core, making cross-platform development possible on Windows, Mac OS, and Linux. The language's static typing and garbage-collected memory model offer a balance of safety and speed, while robust tooling in Visual Studio and Writer streamlines the coding experience. Yet C#'s reach is most profound inside the .NET and Unity ecosystems. Developers outside these domains may find the learning curve steeper and adoption less universal than higher-ranked languages. Still, for anyone eyeing game development or building enterprise apps on .NET, C# is the default. Try starting with a Unity 2-dimensional game or a simple web API. C# is ready for both. In 2012, Anders Hejlsberg, already famous for C#, introduced TypeScript at Microsoft. His goal was to fix JavaScript's Wild West unpredictability by adding static types, but without breaking compatibility. TypeScript code compiles straight to JavaScript, so it runs anywhere the web does. That small change changed everything. By 2025, TypeScript became the most popular language on GitHub, with a 66% jump in contributors in just 1 year. React and Angular, two of the world's most widely used web frameworks, both encourage TypeScript for new projects. Even Slack's desktop app was migrated incrementally, file by file, to TypeScript for better safety and code quality, with no risky full rewrite needed. TypeScript's real draw is safety. It catches bugs before they reach the browser, making massive codebases manageable, and letting developers refactor with confidence. Visual Studio Code, itself written in TypeScript, offers instant feedback and smart completions, helping teams ship faster. For anyone building modern web apps, TypeScript is not just a nice-to-have, it is the new default. Start by adding types to a simple React component and see the difference in minutes. C++ began in 1985, when Bjarne Stroustrup set out to give programmers the power of C with the structure of classes. That combination made C++ the backbone of high-performance software, from operating systems to real-time trading engines. Today, C++ drives the world's most demanding technology. Unreal Engine, the foundation for blockbuster AAA games, is built almost entirely in C++. In finance, high-frequency trading platforms rely on C++ for microsecond-level decisions. The language's static typing and manual memory management offer unmatched control, but they also demand discipline. Every pointer and allocation is the programmer's responsibility. Modern standards like C++20 have brought safer syntax and new features, yet the core trade-off remains: raw speed versus complexity. C++ holds an 8.8% share on the TIOBE index in 2024, proving its staying power in a world chasing efficiency. For anyone drawn to systems, games, or hardware-level code, C++ is irreplaceable. Start with a simple game engine loop or a performance-critical algorithm. Mastery here means mastering the machine. In 2011, JetBrains released Kotlin, naming it after an island near their St. Petersburg office. The language was built to work hand-in-hand with Java, but with a cleaner, more expressive style. By 2017, Google officially endorsed Kotlin as the preferred language for Android app development. That decision changed the mobile landscape almost overnight. Today, nearly every new Android job listing asks for Kotlin, and companies like Pinterest have migrated their Android code to take advantage of its concise syntax and built-in safety features. Kotlin's approach to null safety has cut down on app crashes, saving developers hours of debugging. Its seamless interoperability with Java lets teams modernize old codebases without a risky overhaul. Android Studio, the main tool for mobile developers, now comes with Kotlin support out of the box. Beyond phones, Kotlin multi-platform is gaining traction, letting teams share business logic across Android, iOS, and even back-end systems. For anyone building mobile apps or looking to write once and run everywhere, Kotlin is the clear choice. Start with a simple Android to-do list and see just how much less code you will write. Swift arrived in 2014, unveiled by Chris Latner and the Apple engineering team at WWDC in a rare surprise. Designed from the ground up for safety, speed, and expressiveness, Swift quickly replaced Objective-C as the go-to language for building iOS and macOS apps. The introduction of Swift UI in 2019 accelerated that momentum, making it possible to design complex interfaces with far less code. Today, every major iPhone and Mac app, whether it's from Apple or top names like Airbnb and Robinhood, relies on Swift for new features and performance. Apple's own first-party apps are now written almost entirely in Swift, and the language's automatic reference counting keeps memory management efficient and largely invisible, freeing developers to focus on design. Swift's exclusivity is its strength and its trade-off. Mastering it is non-negotiable for anyone building apps for Apple platforms, but it has little use outside that world. For a first project, a Swift UI Hello World app is the fastest way to see your code running on an iPhone. In 2009, 3 engineers at Google, Rob Pike, Robert Griesemer, and Ken Thompson, set out to solve a problem they knew firsthand. They wanted to make cloud infrastructure simple, reliable, and fast to build. Their answer was Go. Instead of piling on features, they stripped the language down to essentials, focusing on lightning-fast compile times and easy concurrency. Go's Go routines and channels let developers spin up thousands of lightweight tasks in a single program, a model that fit perfectly with the scale of modern cloud systems. This simplicity paid off. Docker, the tool that ignited the container revolution, is written in Go. Kubernetes, the backbone of cloud-native operations, runs on Go as well. According to the 2025 CNCF survey, Go is now the top language for cloud infrastructure worldwide. One standout feature is that Go compiles to a single static binary. That means you can deploy a microservice or command line tool with one file, with no tangled dependencies and no surprises. For engineers building scalable APIs, distributed systems, or DevOps tools, Go's blend of speed and clarity delivers a clear edge. Start with a basic HTTP server or a concurrent file processor. You will see why cloud teams everywhere keep choosing Go. Java began in 1995, when James Gosling and his team at Sun Microsystems set out to solve a problem that plagued software everywhere: how to write code that could run on any machine without endless rewrites. Their answer was the Java Virtual Machine, and the promise was simple: write once, run anywhere. That idea took hold in the world's biggest companies. Today, Java stands as the backbone of enterprise backends, powering everything from global banking systems to the core retail infrastructure at Amazon. The language's static typing and automatic garbage collection bring a sense of order and reliability to massive, long-lived code bases. In 2025, IEEE Spectrum again ranked Java as the top enterprise language, and nearly a third of developer job listings worldwide still mention Java skills. The real engine behind Java's staying power is its ecosystem. The Spring framework, adopted by giants like Netflix and LinkedIn, lets teams build secure, scalable application programming interfaces that can last for decades. Its backward compatibility and rich library support mean old code keeps running, even as new features arrive. For anyone aiming at a career in enterprise software, Java is the safe bet. Start with the Spring Boot REST application programming interface, and you'll see why companies still trust Java with their most critical systems. Python began as Guido van Rossum's holiday project in 1991, driven by the idea that programming should be simple and readable for everyone. That philosophy, clear code over clever tricks, turned Python into the most widely adopted language on Earth. By 2025, Python claimed the #1 spot on the TIOBE index, outpacing every other language in global use. Its strength is versatility. In data science, libraries like NumPy and Pandas let researchers crunch numbers at scale while TensorFlow and PyTorch power breakthroughs in artificial intelligence. Python is the backbone of machine learning at Google, Meta, and Netflix, and it is the first language taught in thousands of universities worldwide. Its design lets beginners build their first web scraper or calculator in minutes, yet it scales up to automate cloud infrastructure or drive advanced research. Python's dynamic typing and automatic memory management mean you can focus on ideas, not boilerplate. The trade-off is speed. Python is not built for raw performance, but its ecosystem more than makes up for it. For anyone curious about AI, automation, or data-driven discovery, Python is the language you will keep coming back to. Start with a Jupyter notebook and see how quickly you can turn data into answers. Which language do you think is going to be the next big thing? Write it in the comments. Also, don't forget to subscribe and leave a like, and I'll see you soon.